You know that split second after you type a prompt and hit enter? Before the AI even thinks about an answer, there's this hidden process that's already shaping everything. How it reads your words, how smart its answer will be, and even how much you're paying for it. Today, we're going on a little mission. We're going to reverse engineer that hidden component, the AI's tokenizer.
So it all starts with this one big question. How does an AI actually read? Because it definitely doesn't see words and sentences the way that we do. Nope. It sees numbers. The whole journey from, hello world to a long string of integers, that all comes down to a process called tokenization.
The best way to think about the tokenizer is like it's the AI's own personal Rosetta Stone. It's this incredibly important translator that chops up our language into little pieces, or tokens, and then gives each piece its own special ID number. And here's why you should care. Every single decision made when building this translator has these huge downstream effects on cost, on accuracy, and on the model's performance as a whole. It's a really big deal.
So here's our game plan for this explainer. First, we're going to track how the AI's vocabulary has exploded. Then, we'll peek inside its new 200,000-word brain. We'll break down the hidden costs for anyone not speaking English. And finally, we'll get into some really practical tips on how you can write better for an AI.
Okay, first up, the evolution of the AI's vocabulary. And let me tell you, this isn't just some small update. We're talking about a massive leap that tells us a whole lot about OpenAI's strategy.
I mean, just look at this. There's a really clear pattern here, right? It all started with GPT-2 back in 2019 with about 50,000 tokens. Then with GPT 3.5 and 4, they doubled it to 100,000, mostly to get better at different languages. And now, they're doubling it again to over 200,000 tokens, and they're even adding clever new tricks to understand things like coding styles. The vocabulary is just exploding.
So, what's the big payoff from having a bigger vocabulary? Well, it makes the AI way more efficient. The impact is actually huge. A piece of Python code that you would have run before now takes 42% fewer tokens. Turkish text is 44% more efficient, and Chinese, a staggering 68% better. This isn't just a technical detail. It means faster results and lower costs, especially if you're a developer or a non-English speaker.
All right, now for the really fun part. Let's crack open this new 200,000 token vocabulary and see what's inside. Because the data itself gives us some fascinating clues about what these AIs are being trained on, and frankly, what OpenAI really cares about.
And the first big clue is right here in the script distribution. Almost 60%, a whopping 60% of the entire vocabulary is dedicated to Latin scripts, like English. Now compare that to CJK scripts, that's Chinese, Japanese, and Korean, which make up a massive part of the internet, but get less than 4% of the vocabulary. This imbalance is pretty significant, and it has real consequences. And hey, don't just take our word for it. We're not the only ones who noticed this. This comment was actually found buried deep inside OpenAI's own source code. One of the developers on the Tokenizer library itself admitted that they could probably allocate these tokens more efficiently. It's this rare little peek behind the curtain, and it totally confirms the imbalance we're seeing in the data.
The way these tokenizers learn also leads to some really weird stuff becoming single tokens. The longest one they found? 128 spaces in a row, probably from some indented code somewhere. You also get common code words, long lines of equal signs for separators, and even entire multi-word phrases in Thai, like Secretariat of the Organization, all being treated as one single unit. It's kind of wild.
So, all of this leads us to a really crucial concept, something people are calling the multilingual tax. Because this imbalance in the vocabulary isn't just some nerdy technical detail, it creates real-world costs for people all over the globe.
Okay, let's just look at a super simple query. What is machine learning? In English, that's 5 tokens. Easy enough. But if you ask that exact same question in French, it suddenly jumps to 9 tokens. That's almost double the cost. And why? Well, it's because things like apostrophes in French force the tokenizer to split words apart, creating extra tokens. So you are literally paying more to ask the exact same question, just in a different language.
To put one hard number on it, a typical sentence in Turkish costs about 1.5 times more in tokens than the same sentence in English. This tax means you can't fit as much into the AI's memory, your API bills are higher, and there are actually more opportunities for errors to creep in, all because of how the tokenizer was designed from the ground up.
There's also this really interesting theory about how all this might be connected to AI hallucinations.
So when a word like Google is a single solid token, the model makes one clean decision to use it. But for a name like OpenAI, which gets split into two tokens, Open and AI, the model has to make two decisions in a row. It's like having to press two buttons instead of one. And that extra step just creates one more chance for the AI to get confused and maybe go off the rails.
Okay, so now that we're armed with all this inside knowledge, how do we adapt? Let's get to the really practical part of this: how to write for an AI. It's a whole new field that some people are starting to call Answer Engine Optimization, or AOE. The power of simple structure here is just immense. Just look at this. Turning that one sentence of prose into a basic bulleted list, it cuts the token count by more than half. It goes from 67 tokens all the way down to 28. And the reason is super simple. You're getting rid of all the little filler words, making your message denser and way more efficient for the AI to understand. So the big takeaway here is just to be direct and to be structured. Always lead with the answer first. Use numbers instead of writing them out as words. And definitely use common abbreviations. MIT is 5 times more token efficient than spelling out the whole thing. Oh, and finally, using little signal words like source or study can help the model see your content as authoritative and something worth citing.
And all of this brings us to one final big question to chew on. We've just seen that writing for an AI means favoring structure, being super efficient, and really direct. But as we all get better at optimizing our writing for machines, how do we make sure we don't lose the nuance, the creativity, and all the wonderful messiness of just being human? That's the real tension we're all going to have to figure out as we move forward.